Hey, thanks everyone. This is good. Thank you, Billy. Where's Billy? Thank you. What you've said there nicely dovetails in what I'm about to say. So, good job. Good job. Thank you. I'm David from Playmint. I know most of you. I think nice to see you all. I was having a conversation with Ian, our CTO here. This was last month. And he said to me, we're not ready to talk about Playerchains yet. So Playerchains is something we've been working on at Playmint for, I don't know, a couple of months, I suppose. And we're definitely not ready to talk about it for a couple of reasons. One is because we still don't know exactly how it's going to work. And also because I don't even know how to describe it properly in a way that everybody understands. So with that, I'm going to talk about Playerchains because I think part of understanding it and seeing how it fits in with everything is just to talk to people about it. And this is like a good crowd of people to sort of share an idea, really. So by way of background, I think you know this already. We're working on a platform called Downstream. And Downstream is a game that lets people create worlds that run fully on chain. And these are worlds that they own. So this is a screenshot of a world that's been built by somebody, I forget who. And they actually own their worlds. So here you can see a list of the worlds that have been built, but importantly, they're owned by the players that built them. So they control what those worlds are and they own those worlds, which is different from how digital worlds are normally built. They're normally built by a platform holder. So anyway, I think probably you know some of that stuff already, but that's the context of what we're trying to do. And a way of thinking about it, I think it's probably the world's biggest game, is it? Roblox, 70 million DAU, absolutely huge, this game. And in a way, we're doing something similar. I mean, you know, what Roblox does is you can build worlds, you can invite your friends, and these are shared social spaces, but what we're doing is you own your world. And I think that's fundamentally different. I think, again, you know this about Roblox, but if you build a world in Roblox, then you don't really own that world, you can't commercialize it, you can't move it somewhere else. So what we're trying to do with Downstream is say, look, this is a different approach. You can still build and share worlds with people, but you're free to do what you want within it. It's not ours, we can't control it, it's censorship resistant, etc. So that's sort of the backdrop of what we're trying to do. Now, those things I just described, like you own your world, you can do what you want, you can commercialize it. And by the way that I think about this is you can build lots of cool stuff in Roblox and Minecraft and Fortnite, but compared with what you can do on the internet, it's tiny. And I think if you can really build a digital world that lets people build really whatever they want, commercialize it however they want, then that's an interesting new thing that the world hasn't seen yet. So to us, that's an important mission. Here's the thing though, so as per my scales, good news, it's your world, you can do what you, etc. Bad news, 1 second latency, gas costs, and no update loop. I mean, and one of the things that we wanted to do is start to talk to Web 2 devs or Roblox devs and say, hey, why don't you, all the good things I just mentioned, the reality is when they try and build something, then they're sort of suffering those compromises, and the compromises, I think, just weigh down too much. So I'm not content with just making Downstream a place for on-chain game builders to build stuff. There's too few of us. So what I think we need to do is open it up to more people, and to do that, I think we have to fix this problem. So that was the sort of backdrop to 3 months ago when we started talking about how we might address that. Here's how our network architecture worked. And by the way, I'm not the most technical person here by a long shot, so this is going to be very sort of simple, abstract ideas. But here's how we've run things in the past. If you imagine this is our game in the blue circle with a bunch of players represented by the pink dots. And our first game that we built was a game called The Crypt, and it ran on Ethereum mainnet. So we obviously the group of players connected to the blockchain, and the gray bar represents the sort of transactions going back and forth. And then, like everybody else, trying to run a game on mainnet is insanity. So as we started to build a second game, it became clear, oh, good news, there's a thing called a layer 2 now, and layer 2's much faster, much cheaper. And so, sure enough, we started using that, and that was downstream. We ran that on Redstone, so, in a way, that's where we are. Another solution, of course, is to run an app-specific chain, and that's something we've done before. We've run on OP-Stack, and we're getting faster here, and maybe we can do a bit more. So, we've tried that approach. But then when we were thinking about how do we make this really accessible to more people, we started to ask, well, why are we talking to a different set of computers at all? Hang on, this is the way that we've achieved decentralization. We've used a blockchain, a public blockchain, but why are we doing that again? And is there a different approach that we could take? So instead, imagine that these are the same group of players, five players playing a game together. So instead, our solution is, why don't we just make a network between the players, a peer-to-peer network between the players, and that is decentralized. There's no centralized part to that at all. And you'll notice that a public blockchain is nowhere in this diagram. So people here are playing a game, let's imagine it's Among Us, 5 people playing that game. It's not connected to any blockchain at all. It's just 5 players playing a peer-to-peer game, and without any server, without any leader, but just running very quickly in a player chain. And of course, you can imagine that there'll be lots of other player chains, people playing games. So here's some attributes of player chains that we think are interesting, and maybe some weaknesses of that idea. First is performance, 30 millisecond updates, but frankly, it's just your network speed at this point. If you ran this on a LAN, then it would be 5 milliseconds. Or if it was trying to go across continents, then it would be 100. But the point is, we're not worried about a block time anymore. We're down to milliseconds, like a significant improvement. No gas fees here. If you think about why gas fees exist, we're incentivizing a different set of computers to run computation on our behalf. And that's the incentive, is the gas fees. Here, the incentive of running a node in a player chain is, I don't want the game to stop. So I'm quite happy to let my computer be used to make sure that this network between us keeps running. That's it. So there's no gas costs. And another thing is that it can use a custom runtime. So I think an easy way of thinking about, the first thing we thought about was, hey, why don't we just run an EVM chain between the players? And we can certainly do that, but we decided what might be more interesting is that what about if these pick dots are just sending the inputs to each other in a provable way, and those inputs are used in a runtime, whatever seems like the best runtime to have. It's just taking inputs from the people playing the game and playing them out deterministically so that everything happens the same on everybody's computer. Then you can introduce types of fog of war, you can use an update tick, you can do random numbers, a bunch of stuff that's just more normal in Web 2 games. So those are sort of significant advantages of that approach, I think. Technically, and very importantly to us, completely decentralized, so there's nothing that connects to any centralized entity, and no one of these nodes is a sort of elevated status. When I used to make Web 2 games, then we had a sort of peer-to-peer with a host where one player was made a host, and that was sort of slightly higher status than the other nodes. Here we have a system where everything has a same status. We're using leaderless DAG consensus rather than CRDTs, so it's a slightly different approach to solve a similar problem. And it runs in a WASM environment. I think initially, at least, we're building that as not in browser, but as a separate piece of code, but in WASM, so they can be deterministic. I think that's maybe my final point. So that's some of those sort of technical attributes. I want to talk a bit about how it connects to the blockchain, but it's important that I'm not technical enough. To me, it's not really a state channel because it's not coming from a blockchain, going into something and then coming back again. But nonetheless, I think there are some things you probably want to use a blockchain for here. So things would include for player ID, for payment rails, for I can imagine that given that this is a provable deterministic environment, you could build a proof and then send that high score to a blockchain. So you can still use it for things that you think are important. But one of the questions I think is important to ask ourselves is, if you're playing that 5-player game of Among Us, you probably, honestly, you don't really need every single one of those actions recorded on chain forever. You probably don't even want your high scores put on chain forever. I mean, so I think it's important to ask what's important to have a permanent record of forever. Maybe for interoperability, I don't want to lose that attribute. I think it's one of the more interesting things about fully on-chain games. But maybe there's a case of writing the state to a chain regularly so that allows people to interoperate. But whatever we think is like the most interesting thing to write to a chain. And for tokens, I think, probably. A point about permissions, and this again is something I'm getting my head around now, because this isn't a trustless environment in the same way as a public blockchain is, so you have to treat, so it works slightly differently. So joining games is permission. That 5-player game of Among Us, you can't just show up and permissionlessly start playing that game. But I think it's interesting to think of things like attestations. So like that could be, and I use a WhatsApp group chat as an example, like the way that we deal with permissions there is which someone vouches for someone and just says, yeah, trust me, he's a good guy, don't worry about it, bring him in. And frankly, you kick him out if they're irritating. So, and still, it's a consensus. So it's not, the risk is not that one person can break the network. It's just that person maybe could invite a bunch of other people and then start a Sybil attack. I don't know, but attestations is an interesting idea. Proof that someone has done something in the past makes you more comfortable with a group formation that includes them. So I'm interested in some of that technology. But importantly, starting games is permissionless. So you don't need anybody's. So permissions work slightly different. Joining a group is permissioned. Starting a group is permissionless. Games are provable if necessary. And again, I think that sometimes fully on-chain games talks in the abstract terms about how everything needs to be trustless and everything needs to be a canonical record of everything. And the reality is that what we've seen in downstream is not that people want to be part of this monolithic world that lives forever. Actually, they want to create worlds for themselves, invite their friends and play those games. And for that, we don't need a set of things that we talk about a lot. Here's where we are as a company with this. So here's this is just a pre-visualization of a tech demo that we're building. So this isn't downstream, obviously. And we thought, what is like the smallest game that we can build just to prove that this thing works and is responsive and that, what is the network latency, that kind of thing. So we're building, what are we calling this? Substream. Substream, there we go, that's what we're calling it anyway. So it's a bit like Subspace, if ever, all too young to remember, but that was a great, massively multiplayer online game called Subspace, and we're saying, can we recreate the same thing in a player chain? So that's a tech demo that we're doing over the next few months. Probably have something to show at DevCon later. So, So yeah, player chain tech demo. I sort of realizing the thing that I just showed you there. And then a player chain game demo. So I think it's a mistake to immediately try and roll that into downstream. So I think we probably need a couple of steps of trying to build a tech demo of it, what I was just shown, then actually building something that looks a bit more like the game that we expect people to build, then roll it into downstream, and then ultimately figuring out how to connect player chains. So we have some ideas, some really interesting ideas, how you join all those blue circles together and have something that feels bigger than the sum of its parts. But that's probably not a 2024 thing. Is that accurate? Yeah, okay. All right, well, that's oh, one last thing is that I cancelled my train ticket to stay here because I thought this was an important thing for us to be at. What I, no, I mean, because I think that my point is like we're all trying different things, right? And I think it's really important that we're at a point now, I think, where there's some really interesting things about fully on-chain and how you solve that and what you use that for, hyper-financializations. I think that sort of the topology, CRDT stuff, the provable things, the cartridge, everybody's like trying slightly different ideas. In a world where nobody has any product market fit, nobody's making any money, nobody has any users, it's really good that everybody's just trying a bunch of different things. I don't know whether the thing that we're building is going to be the thing, but I love the fact that everybody's trying different things and sharing what they're doing. So just want to say that. Thank you, everyone. Any questions, Billy?
How do you do player match discoverability?
How do you do player match discoverability? I think there's probably, I'm going to make something up. Maybe you could use a blockchain for that to say, here's a lobby, and here's a centralized place on a blockchain that you can go and find where the games is being started. Or you share an invite in a Telegram channel or a WhatsApp channel, if it's with your friends. But probably that's a good use of a blockchain to sort of broadcast intent to start a game. But I just made it up just then, so I don't know if it's a good idea.
Well, that becomes one of the most interesting parts of the puzzle. It's group formation, discovering people to play with, and connecting different trusted groups. So it's TBD, and it's an interesting area.
But interesting, Billy, that you see how some of your slides there talked about how do you bring the latency down, and how do you. I think that's an approach to solve some of the things that you talked about. An approach. Yeah. Any other questions? All right. Very good. Thank you, everyone.